Okay, a couple of, in the last little talk, which is literally 2 minutes ago, I talked about multiplying a vector by a scalar. It rescales it, changes its length but not its direction. It can make the length longer or shorter. Or if it's a negative scalar, make it go the opposite direction. We also did the dot product or scalar product. With the scalar product, you can find the angle between two vectors. You go A dot B gives you a scalar. Now we go A cross B gives you a vector. We'll call it a new vector C. And we look at it. Now we use the dot product in 3 dimensions. We could do it in 2 dimensions. Let's just try something to start off with. Well, not quite, because I haven't given you the method yet. We'll do that in a second. Now, we'll begin by defining this via a determinant. We begin with this definition. Put the unit vectors on the top, and A goes in the second row, and B goes in the third row. Now, if we interchange 2 rows of a determinant, we change the sign of a determinant. When you have to look up determinants a little bit for this, by the way. When you're dealing with cofactors, this guy here, that's the cofactor of I. These 2 guys would form the cofactor of J, and these 2 guys would form the cofactors of K. That's a separate class. Maybe I'll give it a class on determinants later on. Anyway, B cross A is a new vector. A cross B gives a new vector. B cross A is the negative of C, so therefore then A cross B is anti-cumulative. Minus negative B cross A. Okay? Now we want to work out these determinants to find the various different components. Each one will correspond to the I, J, and K components. Okay? So, working across the determinant, we go I times a cofactor minus J times this cofactor plus K times this cofactor. What does that mean? We go AZBY minus AYBZ for that one. And then we go well, let's do it a step at a time. The first one is I times AYBZ minus AZBY. Okay, so we've done that one. Now we go on to the J. Change the sign. Every time you swap a row up or down in a determinant, you change the sign. So we go negative J and then plus K. J. These are the 2 terms involved. That's the cofactor. I stuck it in here. xbz minus azbx. Now we go to the k part. K, same thing. K, the cofactor in that case is this guy here. It's that. I just put it in. And that's A cross B. Let's do an example now, but this time using numbers. Grab hold of that in your heads. Now I do things live. It's the difference between Elton John and who doesn't? Who lip syncs? Just about everybody. Madonna. Elton John doesn't lip sync, Madonna does. Most of the heavy rock groups actually, they don't lip sync either. They can't, which is why I like it. All the artists I like do not lip sync. Creedence, everything. Okay, so the vector product, this time we're doing it with numbers. Now I just make up vectors. So we go this cross this. Is you put your ij's and k's in. The next thing is you put in your vectors. This one goes up first. This one goes down here. And now we carry out the procedure just like I've told you before. Now remember, positive, negative, positive. And the cofactors. The I cofactor is this one here. 3 3's minus 2 minus 2. That's that cofactor. The cofactor of J are these four guys here. 2 3's minus 2 times 4. Negative 2 times 4. And the K one, the K gives me this one. 2 times negative 2 minus 3 times 4. Now, at home, if you think I make a mistake, you can see if you can spot it. And they're the numbers I get. You can work them out at home. So I get A cross B is 5i minus 14j minus 16k. And if I was to graph these vectors, I would find the following. Now I'm not drawing it to scale, but if this was A and this was B, A cross B is a vector at right angles to the plane that they make together. Two vectors generate a plane. The cross product will make a vector at right angles to that plane. Now, if I go B cross A, it will be a vector over here. It follows the right-hand rule because, oh, I made a mistake, sorry. Follows the right-hand rule. A cross B gives me a vector in that direction because if you're screwing in a light bulb, you have to twist it this way to go that way. Think about that. That's the right-hand rule. A cross B. All right. B cross A, on the other hand, that will give me a vector this way. Let's do something else. Something related to the whole business still. Okay. Where do these vector products cross up? Vector products come up in angular momentum. They also crop up in electricity and magnetism, a thing called the Poynting vector. Poynting vector, we won't go into that. Angular momentum will be in classical mechanics. All right. Let's do this. Take these two vectors. Just like that. Neither of these two vectors have k components. So we put in 0 for the k components. And we put in our I, j, k times the cofactors in this determinant. These are the cofactors. Well, 0 times 4 plus 3 times 0 is 0. Now for this one, j, 2 times 0 and 0 times 6 is 0. And for the k, 2 times 3 now hold on a second. That's weird. For the k component, 2 3s is 6. 6 minus 6 times. So we get that. I guess it works. All right, maybe this works. 6 not. It's strange, not what I expected. Never mind, maybe I made a mistake. So A cross B in this case gives me a vector in the k direction. Okay, it works. However, here's something interesting. If there was no space in between, all right, it works, it's fine. So we had two vectors in the xy direction, and we cross product them, and we get a vector in the k direction. Very good, actually I see that, that's quite nice. So, yeah, these are defined only in the x and y plane, and the cross product is in the k plane. Excellent. Now I'm going to look at a much more elegant formulation of the cross product, and I'm going to leave it in the next lecture because it's a separate little idea. We'll use the Levi-Civita symbol to work in the same cross product for vectors. We'll stop there and I'll file this one separately. Oh yes, you don't see this in the ordinary textbooks. I don't know why they filled college physics with such garbage and leave out the really nice stuff and the stuff that might motivate people to go further into physics. But there's another one as well. You know, I hate also glossying up the topic. The topic speaks for itself. If you don't like it, go away and learn something else. Go listen to MTV. Do some art. I'm a great painter actually. I've got works I did all around my house. I paint as well. If you're a physicist, doesn't mean you can't paint. I've got reams of poetry. I've got a book of poetry that I've written. Look at, you know, being mathematically inclined or being artistically inclined, they're not separate ideas, they're all related. Leonardo da Vinci, Michelangelo, they did everything, do everything. So what I'm going to say is this: I will not glossy up work, make it colourful to entertain you guys. So I'm hoping that the people, let's say, who want to learn stuff, if they're in America or China or India, I don't care, that they just pick up on that as an idea. It's what I'm trying to generate. You know, I don't come in here with a PowerPoint lecture. I don't come in here with fancy graphics. It's live on the board. This guy I want to talk about, Levi-Civita's symbol, and it's really wonderful. With that, I will teach you also the Einstein summation convention, which is phenomenal. Okay, we'll do that next time.